This video, we're going to evaluate a formula for given values. This is very similar to what we did in 6.1, where we evaluated expressions for a particular value, but this time there's an equal sign in the problem where we're going to be plugging numbers in on both sides of the equation. Or potentially doing that. So let's go ahead and get started here. These problems are like those from 6.2, numbers 5, 11, 15, 17, 19, 21, 23, and 29. Let's go ahead and get started here. We're going to start off with the formula for kinetic energy. Or nope, I'm going to actually start off with the formula for perimeter, excuse me. So P is equal to 2L plus 2W. You might see sometimes where those are lowercase letters. You might also see this equation with the 2 factored out front. It doesn't matter either way, but in this problem, it was written this way as 2L plus 2W. They tell us that they want to evaluate this to find what P would equal when L is equal to 83 and W is equal to 97. That's a pretty big rectangle. If those are anything of significant size, if they're like millimeters, then it's not very big of a rectangle, but we don't have any units here to give us idea of what these quantities represent. We just know those are some pretty significant numbers to us, that we're going to end up with a big number here. So P is equal to 166 plus 194. And then 6 plus 4 is 10. And 10 plus 6 is 16. 2 plus 1 is 3. So my perimeter should be 360 units of some kind. They're just going to make you put 360 in there. But when you do these problems with formulas, lots of times you have to pay attention to the units and answer with units. These are usually application problems. And so pay attention to that. That in maybe this section is not going to ask you to do that in my labs, but that's very important for you to know that these formulas give you particular units, and you should get the same units on the left and on the right. Number 11 here is K, which is kinetic energy for us here, is 1/2 mv squared. And they're going to tell us that they want us to find m when v, the velocity, is equal to 38 and k is equal to 2688. So we're not going to go ahead and rearrange this yet because that's another video that's coming up. We're just going to make this 2688 is equal to 1/2 m times v is 38 squared. And so let's look at what 38 squared is here. Actually, let's do this. 2688 equals 1/2 of 38 times 38 times m. And this is going to be 19. Now let's look at what 38 times 19 is. 38 times 20 minus 1 is 760 minus 38 is 760 minus 40 plus 2 is 720 plus 2 is 722. Let me just check that with my calculator here. Um, $38 squared divided by 2 is 722. Yep. I'm going to divide by 722. 2688 divided by 722 is a decimal. I want to convert to a fraction. So we're just going to divide both of these by 2 is going to be 1344 divided by 361. That's exactly what M is, and they tell us to simplify our answer. They don't tell us to round at all. So that's as far as we're going to go with that. All right. Again, that quantity would be a mass in the formula, so we would be expecting something in grams or kilograms, something like that, if we were doing this in a, say, a physics class. All right, now we've got velocity is equal to 1/2, -1/2, a, which is acceleration, times time squared, where they want us to find a when v is equal to 3375 and t is equal to 15. So 3375 equals -1/2 a times 15 squared. 3375 is equal to -1/2 times 225 times a. So -2 times 3375 divided by 225 is equal to a. And let's figure out what that is. -2 times 3375 divided by 225 is -30. All right. Now we have V for volume equals pi r squared h. This is the volume of a right circular cylinder. They're going to tell us the volume is 2198, and they want us to approximate pi as 3.14, and they want to tell us that r is 10, and they want us to find h. So 2198 equals 3.14 times 10 squared times h. So this is going to be 100 divided by 314, and h is going to be 3198 over 314. See if that reduces at all. So that's going to be, and this is an approximation because we approximated pi. So this is about 1599 over 157. That's if I divided both of those numbers by 2. And that's my exact answer. We're not told to round, so we will leave it just like that. Now we're going to use the formula to convert between Celsius and Fahrenheit. It's an important formula. Memorize it if you can. So here's to go from Celsius to Fahrenheit. and they want us to change 18 degrees, which is about room temperature. So I'm going to say F equals 9/5 times 18 plus 32. So we're going to say that this is 72, 162 over 5 plus 32. F is 3, 2, and 2/5 is 0.4. So F is 64.4 degrees Fahrenheit, like that. So somewhere around 18 to 20 degrees is usually where people keep their thermostat in their house for room temperature in Celsius. That's a pretty typical thing for us to use there for a room temperature setting. So it's a little on the chilly side for room temperature, but there it is. Now that slope formula that we talked about in our last video, and they want us to say that x1 is equal to 4 and x2 is equal to 12 and y1 is equal to 4 and y2 is equal to 6. And they want us to find the slope. So slope is going to be 6 minus 4 over 12 minus 4 is going to be 2 over 8 is going to be 1/4. And yeah, that specifically said to type an integer or a simplified fraction. We're not supposed to type the decimal equivalent there. All right. Next one is another important formula from math called the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is how we solve an equation that looks like this, just so you know what this is for. We're not going to be doing much of that in this class. That's more something that you would be doing if you were taking Math 161. But just so you know what this formula is, it's an important one called the quadratic formula, because that's in this form ax squared plus bx plus c equals 0 is called a quadratic equation. So this is the quadratic formula. And they want us to solve this when a equals 2, b equals -2, and c equals -4, meaning that we're trying to find where 2x squared minus 2x minus 4 equals 0. We really could simplify that problem by dividing everything by 2, but they don't want us to do that. Let's just solve it the way that they gave it to us. -2 plus or minus the square root of -2 squared minus 4 times 2 times -4 all over 2 times 2. X is equal to the opposite of a -2 is a +2, plus or minus the square root of -2 squared is 4. -4 times 2 is -8. -2 times -4 is +32. Over 2 times 2 is 4. We're still obeying the order of operations. I'm just doing things that don't affect each other with the plus or minus signs here in between them. So 2 plus or minus 6 over 4. So 2 minus 6 is a negative 4 over 4. I'm going to say that this is my x1 answer. My x2 answer, that's going to be the addition. 2 plus 6 is 8 over 4. So this is a negative 1, and this is a positive 2. I could also just say x equals this, or x equals that. It can't be both things at the same time, obviously. It's not an and statement, it's an or statement. So let's go ahead and do one more example here, which we're going to do the accumulated value of a investment or loan that has compounding interest. Let's zoom back in a little bit here. And we have A for the accumulated value is equal to P, which is the principal, times 1 plus R is the interest rate, over N is the number of payment cycles per year, to the NT. Again, N is the number of payment cycles per year, and T is the number of years. So we have P is $4,000, and R is equal to 7%, which as a decimal is 0.07. N is equal to 4, meaning we're making quarterly payments. T is equal to 4, meaning this is for 4 years. So our accumulated value, let's say that we borrowed $4,000 at an APR of 7%, and we have to pay quarterly for 4 years. What is the total amount that we are going to pay back both principal and interest? That would be something that would be using this formula to solve here. So 4,001 plus 0.07 over 4 to the 4 times 4. A equals 4,000 times 1.0175 to the 16. And this is the calculator time. So there are some problems you have to use the calculator for in this class. This is a good example of one of them. 4,000 times, let's just check that before I go any further. Yes, that to the 16th power, that times 4,000 is going to be 5279.72 when I round it to the nearest cent, which is probably what they ask us to do here. Yeah, round to the nearest hundredth, which is the nearest cent. So we're talking about, for instance, if we borrowed $4,000, we're going to have to pay back $5,200, $5,279.72. When we pay back both principal and interest, we're going to have a whole chapter later on financial math to talk more about these types of interest formulas and things. We'll do lots of problems like that later. So don't worry about if you didn't understand one or two of these formulas. Most of these formulas are going to come up in other applications that we're going to do in this class, whether it's geometry problems or it's financial math problems or algebra problems. And we're going to be doing lots of things with perimeter, area, volume, um, and so on. But just before we get into any of those applications, we just generally want to talk about why do we use formulas? We use formulas because they're the relationship that expresses how these variables, these numbers are related to one another always, all the time. And then if I know all but one of those numbers, I can solve for what number is missing. So they're usually already solved for the variable that we solve for most often. But the next thing that we're going to be able to do is rearrange the formula to solve for a different variable. And that's what our next video is going to do in 6.2 is solve for a variable in a formula or equation. And that's going to make this whole process easier if the variable that was on the left-hand side is not the missing variable. So I kind of wish that they would have done that first, but we'll come back and we will do that next time. See you for the next video.